I want to look at a problem like this. So this is going to be 28 feet. This is going to be 36 feet. This here will be 48 feet. And over here, this is going to be 60 feet. This angle right here, let's call that one 140 degrees. Find the area of this. You guys tell me what to do here. Like this? Like that. Okay. So we cut off the rectangles. Now we're going to need to know this dimension and this dimension eventually to know those rectangles, aren't we? But we have to focus on that shape in there. What do we do with that shape? These are right angles. What's this angle here? 140. What's this angle down here? 40 degrees, perfect. 360 minus 140 minus 90 ends up with 40. Or you could look at it, it's a four-sided figure. It has to have 100 or 360 degrees angle sum. You could do it that way as well. Then what do we do? From right angle to right angle, we connect it, okay? We know 36 and 28, you are correct. Call this side C. How do we find side C? Perfect. Notice I put the square root over it just so I don't have to do it later. So 36 squared plus 28 squared minus 2 times 36 times 28 times cosine of 40 degrees. 23.14 feet. Does that look right to you guys? It is probably this. We don't know for sure if it's the smallest angle, but it probably is. 23.14 feet. Let's find this angle here. Why am I going for that angle? 28 is the smaller side. So how are we going to find that angle? (23.14) over the sine of 40. That's its opposite side angle. Okay, 28 over the sine of that angle. So we will cross multiply and divide to find the sine of that angle. Sine of 40, make sure you close that parentheses again, times 28 divided by 23.14. Then we got to do inverse sine. 51.06 degrees. So there's two things. This is 51.06 degrees. That makes this over here 38.94 degrees, correct? Is that up to 90? What's that tell us about this one down here? How do we get that? They add up to 180. Very good. So that makes this one here 1.06. That's a tiny little angle. Now what? We got to find these two sides. I'll call this D and E up here, right? So how do we find them? Well, so we got the 23.14 equals, let's do D over the sine of 1.06 degrees, right? Cross multiply and divide 23.14 times the sine of 1.06 divided by the sine of 140. So we get, that's just a little 0.67 feet. So it's only 8 inches. E, 23.14 over the sine of 140 degrees equals E over the sine of 38.96. So we'll cross multiply and divide there. 23.14 times the sine, 38.96 divided, oops, gotta close my parentheses, divided by the sine of 140. 22.64. This is 22.64 feet. So over here, what's this tell us for length A here? So 47.33 feet. In other words, 47 feet 4 inches. B is 60 minus the 22.64, which is 37.36. And then we'll find our areas. We've got area 1, area 2, area 3, and area 4, right? Area 1 is 36 times 47.33. 1703.9, we'll call it. 2 is going to be 37.36 times 28. Yeah, 1046.1, we'll call it. 3 is going to be, remember, we can do 2 sides and the angle in between them. So 36 times 28 times the sine of 40 degrees over 2. $324 we'll call it, 324.0. And the fourth one here will be the 0.67 times 22.64. Times the sine of 140 over 2. Giving us 4.9 square feet. That's a skinny little triangle. So 3,078.9 square feet. Okay, so in your notes, I want you guys to try this. We're gonna go 20 feet here. $120 degrees for this angle. This over here, we're gonna make 16 feet. I'm gonna call this up here, we'll go 30 feet here, 50 feet here. Find the area. Assume, of course, that these are right angles in the corner, even though my drawing sucks. I want you in your notes, take about 6 or 7 minutes. Find that area. Let's see how this is going. So we're gonna cut it like that. We're gonna redraw that figure here. What's this angle right here? 60. Of course, 90, 120, and 90. We cut this across here. What'd you get for a length? 18.33 feet. Okay, what'd you get for this angle? 49.10 degrees. Makes this one over here 40.90 degrees, right? This one down here, 70.90. This one over here, 9.1, or not 9, 19.1 degrees, 10 degrees. Look good? Okay. Got 20 and 16 here and here. What'd you get for this distance? Up here. 6.93. How about over here? 13.86. So what's this become then? By 3.07. And this one? 0.14. Very good. Areas right here. Yes, 461.4 square feet. This one over here. We'll just go 0.3. This little piece up here. What's the bigger one? Okay, I'll give you a second to do the little one quick. Puncher, and it's just going to be 6.93 times 13.86 times sine of 120 divided by 2. $41.6. So if we add those all up, we get, what, 503, 641.6, 1219.9, looks right, square feet. Good job. Not so bad? Not yet? I'm sensing a lack of trust. Not a lack of trust, it's a wealth of knowing. Okay, so let's say this ridge here is 52 feet. We're going to give this over here 38-foot span. This is going to stick out 20 feet. This is going to be 36 feet here. Let's give this slope a 612 slope. This slope here is going to be, well, let's make it a 1012. Oops, I said 36 feet. This should have been 16, not 36. There. This is going to be a 1012 slope. Find the roof area. Now, tell me where to start. $19, okay. H over 19. So it's 9.5 feet of height. And then So square root of 9.5 squared plus 19 squared gives us 21.24 feet. So then what? So 21.24 times that 52 length ridge is 1104.48. We're gonna call it 1104.5. Why am I writing it down twice? Yeah, because there's this side over here too, right? We're gonna have to correct that side by doing what? Yeah, there's a triangle in here where this dormer hits the roof that we have to subtract out, don't we? But we're also gonna have to add in the dormer itself. Okay, so we're gonna do the same thing with the 16s we did with the 38. Do that, then what? 10 over 12 equals h over 8, which gives us 6.67, look right? Yeah, okay. So that's 6.67 feet tall. And then? Okay, so what's that give us? $10.41 feet, okay. Now we got 20 feet here, but we need to know the length of that ridge, don't we? I'll give you a hint here. Let's look at this thing from the end. What do we know about that? You know, this is 20, yep. Do you know this height here? This is it's this height right here we're looking at from the side. 6.67. Okay. What that means is this height right here is also 6.67. If I want to find this distance here, which would be this part, the same as this is the ridge, right? What do? That's a 612 slope, right? We're blank, right? Does that give us 13.32? 33, something like that? 13.33, I believe. Does that look right? 3.4? Okay. So it's 13.34 feet, which means that whole ridge, you got it, 33.34. So to find the area of that trapezoid, it's the average of the bases, 33.34, plus, what's the other base? 20, divided by 2, and then times the 10.41, right? Then there's going to be 2 of them, so we're multiply by 2. So 33.34 plus 20. Now make sure you hit equals before you divide by 2. And then times the 10.41. Then we're going to just multiply it by 2. 555.3 square feet. If we add that all up, we get 2764.3. But what do we still need to do there? Take out that triangle. Good. We know that triangle is 16 feet wide because that's the width of that dormer, right? We don't know the height. That height goes up the slope, but that would come from right here. So how do we find that? Pythagorean theorem will give us what? Yep, 14.91 feet. So 14.91 times 16 divided by 2, of course, because it is triangle, 119.3 feet that have to come out. So we subtract that out, we get 2,645.0 square feet. What do you think? Not so hard? Better than a sharp stick in the eye? Okay. This next one is going to stretch my artistic abilities a little bit. So let's say this here is 32 feet across. We're going to make this up here 56 feet. This end slope here, let's make that an 812 slope. The side slope here, let's make this a 612 slope. I want to find a few things here. One of the things I would like to find is I would like to find this angle right there. I'll call that angle theta. I would like to find this angle right here. I'm going to call that angle alpha. I want to find the length of the common rafter. Call that L. I want to find the length of the ridge up here. I'm going to call that D. That'll be good enough for now. And I want to find, of course, the area of the roof. That'll be the easy part. So working on something like this, there's a couple of triangles we can find in this. It's kind of like when we did our hip, this is a hip roof, of course. But when we did our hip rafter length calculations, we started with a common rafter. That's what we're going to start with here. Of course, what's the span of that common rafter? 32 feet, and it has a slope of 6. So what do we do? Okay, we cut the 32.5, gives us a run of 16. It is 6 over 12 equals that rise of h over 16. Gives us that h is 8 feet. Now we can find L. How do we find L? You got square root of. Perfect. What does that give us? $17.89, right? 17.89 feet. So I'm going to draw that over here. That's 17.89 feet. Now, the next triangle I'm going to look at is going to be on the hip roof here. Actually, it comes down to the center of that hip roof. That's going to be our longest jack. I'm going to draw this triangle in here sunk down into the roof. So if I look at that triangle, what dimensions do I know of that triangle? No, the height is 8 feet because it has to be that same height, right? And I know the 8 slope, right? So I can find this setback down here. this dimension right there. Because 8 over 12 equals that rise of 8 over x. Well, x just comes out to be 12 feet. So this here is 12 feet. What's that slope length? You got it. 1442. We're going to need that one later to find areas. Now, what's this ridge up here? What's that ridge length? I'll give you a hint. What's this here? We took 12 feet off of each end from the 56, makes that 32 feet. Now we have everything we need to find the areas here. We have this triangle here that's 32 by 14. 32 times 14.42 over 2, but times 2 because there's 2 of them, right? There's one on the other end. Gives us 461.44 square feet. And then here, the trapezoid with bases of 56 and 32 over 2 times that height of 17.89. And of course times 2 because there's 2 of those. US 1574.32 square feet, which is going to add up to be 2,035.76 square feet. Not great? Well, there's still a matter of some angles to find. Let's find theta right here first. Theta is actually broken down into 2 pieces. This angle right here I know is 90 degrees, isn't it? This triangle, that's a right angle there. I know this is 17.89 and this is 12. How would I find that angle? I got a right angle, so I can just use a regular trig function, right? That's an inverse tangent of opposite 12 over adjacent 17.89. So I get 33.85 degrees plus the 90, that makes that angle 123.85 degrees. That was theta. Now let's look over here at alpha. Alpha is going to be found off of that triangle. Because I know that this side of the triangle is half the 32, that's 16, and that slope is 1442, right? Right there. So we can find this angle right, come on, right here is the inverse tangent of, which one goes on top? 16 over 1442, perfect. Second tangent, 16 divided by 14.42. 47.97. How do I get the angle from there? Double it, right? So the whole angle is 95.95. That equals angle alpha. What do you guys think? Not horrible? Ready for a quiz? Throw it at you.